The Fungible DPU Software, a suite of software solutions that provides an agile, out-of-the-box, and future-proof experience for fungible DPU users. One of the key innovations in the fungible DPU is a data path engine that can execute data-centric computations at extremely high speeds. Data-centric computations include network, storage, security, virtualization functions that run on the data path. This data path engine is fully programmable. The Fungible DPU data path engine comprises hundreds of hardware threads that can execute these data-centric computations. The programmability of the data path engine allows the Fungible DPU to take on different distinct personalities, and even multiple personalities at once. Let's take a look at the first persona, where the Fungible DPU sits in a PCIe target, such as a storage, AI, and analytics server. The Fungible DPU acts as a root complex to PCIe devices, such as SSDs, GPUs, and FPGAs. In the storage target, the Fungible DPU takes the place of the NIC and the CPU-based storage controller, serving as a full-featured high-performance storage controller for NVMe SSDs. The Fungible DPU, in fact, enables a pool of disaggregated SSDs to be presented as a large SSD vended over the network via NVMe-over-Fabrics protocols to host servers. To support this persona, the Fungible DPU is programmable to support a multitude of functions. To efficiently support ingress and egress data interchange, the Fungible DPU supports modern protocols such as NVMe and NVMe-over-Fabrics. The Fungible DPU also fully implements the storage stack, supporting raw and durable volumes, storage services such as compression, deduplication, snapshots, cloning, and security services such as encryption. To complement the Fungible DPU on the storage target, the Fungible DPU can also be integrated into host servers, serving as a bare metal NVMe-over-Fabrics storage initiator. The Fungible DPU translates NVMe to NVMe-over-Fabrics, making NVMe remote storage appear local to the host servers. The Fungible DPU also executes data services, such as end-to-end encryption for data security and compression for more efficient network bandwidth utilization. On the host side, the Fungible DPU can take on multiple other personas. A use case that is surging in popularity is bare metal virtualization, or BMV. BMV allows applications to achieve performance close to that of bare metal servers, making this use case highly attractive for applications that are performance and latency sensitive. BMV is realized by offloading functions such as I/O virtualization, networking, storage, and security functions into the Fungible DPU. The Fungible DPU supports data interchange through PCIe SRIOV and I/O virtualization in hardware. It also offers full programmability of networking, storage, and security services. Firstly, the Fungible DPU offers the flexibility to customize network functions and protocols. For example, virtual switching, routing, network overlays, load balancing, and so on. Secondly, the Fungible DPU offloads the storage stack from the CPU, supporting both local and remote storage, while also enabling storage data services such as compression, encryption, and analytics. Thirdly, the Fungible DPU supports stateful firewall, authentication, and cryptographic protocols such as IPsec and TLS, deep packet inspection, and so on. To support this level of flexibility, the Fungible DPU supports eBPF programming. eBPF programming provides small pinhole APIs that allow users to customize specific functionality. To name a few examples: checking the validity of a packet, modifying encapsulation of packet headers, customizing compression algorithms. Next, the Fungible DPU can also serve as a standalone security appliance or a distributed security node in host servers. In both cases, the Fungible DPU operates as a security hub that delivers comprehensive protection for data entering and exiting data centers and data moving laterally within the servers in the data centers. The fungible DPU can also act as a look-aside accelerator, offloading the CPU for functions such as encryption, asymmetric cryptography, compression for both text and images, deep packet inspection, and filtering. The Fungible software suite includes drivers for the host OS and accelerator libraries that will allow the host to offload these functions into the Fungible DPU. Lastly, while the Fungible DPU is designed for massively scale-out, composable, disaggregated infrastructure, the Fungible DPU can also supercharge your hyper-converged infrastructure. Combining multiple personas, the PCIe ports can be configured to support both root complex and endpoint. The Fungible DPU acts as the data path hub, bridging the network and the compute and storage resources in the hyper-converged servers. Under the hood, the programmable data path in the Fungible DPU is enabled by an operating system known as FunOS. FunOS manages how data is processed in the Fungible DPU, processing parallel streams of data that traverse seamlessly between the processing cores and hardware accelerators. Both Fungible DPU and FunOS are carefully co-designed to process a large number of requests coming in at line speed. Each request is part of a flow. There are tens of thousands of flows in the DPU, each flexibly constructed to support a mix of data-centric computations. For example, storage, networking, security data path functions. Typically, a flow is broken down into pipeline stages. Depending on the function, some stages of the pipeline can be implemented in software, leveraging classical cores, while others can be implemented on hardware accelerator blocks, such as compression engines, pattern matcher engines, and so on. FunOS makes it easy to mix and match software routines and hardware blocks. The API, whether to run a function on software and hardware, is the same. The APIs are also composable, making it possible to break down a flow into reusable subflows. Further, the APIs are asynchronous, enabling tasks to be easily and quickly organized. The Fungible DPU is designed to switch from one subtask to another in tens of nanoseconds, and this performance is scalable to tens of thousands of flows. Try doing that with a classic OS running on a classic architecture. With the DPU handling fine, granular operations and turning them into bulk operations that are friendly to the host CPU, the host I/O software becomes drastically simplified and more efficient. The careful hardware-software co-design has enabled a unique combination of performance and flexibility, resulting in data paths that are fundamentally more efficient, achieving higher throughput, lower latency, and consuming less power. So far, we have described how programmability enables features, flexibility, and performance on the different data paths. But that's just half the story. The Fungible DPU is designed to have a control plane that is distinctly separate from the data plane and is serviced by a set of processors controlled through the management ports. To manage the control plane, Fungible offers a set of management services known as the cluster services. The cluster services offer an agile, scale-out, single pane of glass management console responsible for managing storage services such as adding and removing nodes, setting volume attributes and quality of service, enabling features such as snapshots and clones, network services such as network and port configuration, LACP configuration, and IP address management, system services such as telemetry and health monitoring services, security services such as authentication, authorization, and auditing, support services such as call home and remote assist. The cluster services are accessed through a set of REST APIs that allows these services to be integrated into standard orchestration systems such as Kubernetes CSI plugins. The power of the Fungible DPU is clearly unleashed through its programmability. The Fungible DPU offers flexibility comparable to general-purpose CPUs, processing all forms of data, networking, storage, security, analytics, and more. Yet it achieves performance that is comparable to ASICs. That makes the Fungible DPU truly unique and worthy of being the third socket in data centers alongside the CPU and the GPU.